Okay, so for Math 99 Week 1, I'm just going to focus on some of the topics in Math 112 that students in the past have struggled with. For Math 112 this week, we're covering sections 2.1 and 2.2, so I'm just picking out some of the topics that have historically been a problem area for students. It doesn't mean that these will be a problem area for you, but maybe it is, maybe it's not. So the first one's cardinality. The cardinality is the number of elements in a set. I know it sounds like it's some super sexy name or something, but it really is not. It's just, the number of elements in a set. So the cardinality is just counting. That's all it is. These little curly braces are just denoting a set, and it really is just 1, 2, 3, 4, 5. 5 elements in the set. So we write that as the number of things in set A is 5. Just that easy. But where it gets tricky is like some of these other examples here. So like set B, how many things are inside these curly braces? Well, nothing. So we say that the cardinality is 0. The number of things in set B is 0. This is also the empty set because it is a set that is empty. We know that you could also write this as a circle with a slash through it. Okay, so just keep that in mind. Set C, how many things are in this set? Well, just one, just a triangle. So we say that its cardinality is 1. The number of things in set C is 1. Now, for D, how many things are in this set? This one's really tricky because you're like, well, that's the empty set symbol, and it is. But because these are used together and we have something within this set, that cardinality is actually 1. Okay? So this by itself is the empty set. This little symbol, the circle with the line through it, that's the empty set. So if these little curly braces weren't there, that cardinality would be 0. But when you put them together, they mean something totally different. Okay? Individually, they mean the empty set. But together, that's a set with one thing in it. It's got a circle with a slash through it. All right, and then another thing that often is confusing for students is sets that have this little dot, dot, dot. Some students will mistakenly think that there's only 4 things in this set. That would be true if it weren't for the dot, dot, dot. The little dot, dot, dot means that this pattern continues on. Okay? That means that 1, 2, 3, this is the abbreviation for us not having to write 4, 5, 6, 7, 8, 9, all the way up to 75. So the cardinality for that set is 75. So pay close attention to that dot, dot, dot business. Okay? Next up is equal and equivalent sets. Equal sets have exactly the same elements. Okay? Equivalent sets have only the same cardinality. Now they may have the same elements, but they don't have to. Okay? They just have the same cardinality. So let's look at these in pairs and determine if it's equal, equivalent, or neither. So A and F here. A is the set 2, 10, 21, 50, 67, and F is the set 50, 67, 21, 2, 10. Even though they're in a different order, those two sets have exactly the same elements. Oh, but wait. Not only do they have exactly the same elements, but they also have the same cardinality. So these sets are both equal and equivalent. Now we don't actually have to write the equivalent part. That's understood. That's a given. If 2 sets are equal, they are always going to be equivalent as well. If you have 2 sets that are exactly the same, then of course they're going to have the same cardinality. They're exactly the same. Okay, let's look at another one. How about M being the set 2, 5, 8, 12, and N being the set blue, pink? All right, well, these are obviously not the same set, right? Do they have the same cardinality? Oh, no. That one's got, a cardinality of 4. That one's got a cardinality of 2. These are neither equal nor equivalent. So I know that in everyday language we tend to use the terms equal and equivalent as synonyms, but they are not mathematically the same. Okay, how about M being 2, 5, 8, 12, and P being the set blue, pink, red, yellow? Well, they both have a cardinality of 4, but they're not exactly the same elements. So these two sets are equivalent. So remember, two equal sets are always going to be equivalent, but two equivalent sets, they may or may not be equal. So that's a question that often shows up in ALEKS. All right, lastly, let's talk about like complements and things like that, unions, intersections, and stuff. So U represents the universe. That's the set of things that we're going to be discussing. In this case, I put months of the year. A being January, February, March, April. B being February, April. C, January, March, May, July, September. And D, November, December. So the first one that I want you to find is A with this little symbol right here. That little symbol is a complement symbol. And it represents the stuff in the universe, but is not in set A. Complement is associated with the word not. So it's just the months of the year that are not January, February, March, April. Okay? So the months of the year that are not January, February, March, April, that are not in set A. So there we go. Next up is the intersection. So that's what this symbol means. And remember, intersection is the overlap, or what the two sets have in common. So if we look at sets A and C, what do they have in common? What is something that is in both A and C? Well, January and March. So we say that's their overlap. That's the two things that are in common with A and C. The union of A and C is just the smushing together of sets A and C. All you got to do is just smush A and C together and just don't write anything twice. So I wrote A, January, February, March, April, and then I went to C. January I already had, didn't write it again. March I already had, didn't write it again. May, July, September. So what I tend to do with my unions is I tend to write all of this first one set first, and then I just start writing this set and just don't duplicate anything. So the union's just smushing them together. The intersection is what is looking for what's in common or what's shared. Now B and D, that's a little trickier. That's an intersection. It's what they have in common. If you look at B, February, April, and D, November, December, you'll see they have nothing in common. But if you look at their union and you just smush them together, you get February, April, November, December. Just smushing B and D together. That's the union. Now, if we get a little bit weirder about this, and we talk about this union, but the complement of it, well, now this is the stuff that's in our universe. That's the months that's not in this set, that B union D. So it's the months of the year that's not these. So we're going to write all the months of the year, but not those, because that complement of this set, so BUD is right here. So January, not February, March, not April, May, June, July, August, September, October, not November, not December. All right, C complement, we have to go back up here to set C, is the stuff in the universe. So it's the months that's not January, March, May, July, September. So remember, complement is not. So it's just the months of the year, stuff in the universe, but not in set C. And then lastly here, this looks a lot more menacing than it really is. This is just the intersection of these two sets. Okay? A complement we found up here in part A. C complement we found in part G. We're just going to take the overlap of the answers from Part A and Part G. So looking at A, that set, and then looking at Part G here, looking at that set, this is an intersection, so it's the overlap or what's shared. So comparing A and G here, you can see that what they share, what they have in common is June, August, October, November, December. This one, the union, still going to use this set up here and this set here, but now I'm smushing them together. That's what the union does. So I just need to smush those two together and don't write anything twice. Okay. So I hope this helps with sections 2.1 and 2.2, and I hope it helps you with your in-class assignment with your first one, your ICA 1.